So today we are going to start Big M method. This is another method to solve LPB. So why we need this Big M method, or we can say sometime artificial variable method. So why we need that, what is the shortcoming of simplex method, so that we are going to discuss in motivation. So that is the first section we will discuss. Then we will see what is the actual algorithm of Big M method. After discussing the concept, we will see the algorithm of Big M method or Big M algorithm. Then we will use this algorithm in an example problem and we will solve one LPP to understand how to apply Big M algorithm and get the optimal solution. And the last section is containing your some examples or some problems that you have to do as a homework, so that you will get good grip at this method. Okay. So let us start with motivation. Okay, we will see now the motivation part. So till now, whatever LPB we have used, or whatever technique we have used, that is first we have seen the simplex method. So in simplex method, what we have seen, the observed that the introduction of slack or surplus variable provide initial basic feasible solution. So in simplex method, actually what happens, simplex method, the first is that construct the table, initial basic table, initial, we have to find the initial simplex table. There we use, or we consider the basic feasible solution first, then we start the process, then we search the optimal solution. But what we observe, but there are many LPP where the constraints are greater than equal to or equal to type and slack variable fail to give such a solution. For example, what type of problem we have seen? So maximize z subject to the constraints maybe it was written like a11 x1 plus a12 x2, okay, is less than type. If maximization, then we have less than type, so maybe b1, then a21 x1 plus a22 x2 plus a23 x3, let it be less than equal to b2. So we had like less than equal to sign for maximization problem. So for minimization problem we have greater than equal to sign. Now we are concentrating on maximization, because we know, if we know maximization problem, then we can apply our previous techniques what we have discussed in the previous classes. So those technique we can convert it to minimize problem, or you can solve the minimization problem. Now if maximization problem is there, we will have less than equal to type of inequality. But in some problem you will have maximization type of objective function still, or maximization problem still you have greater than equal to inequality, or you have mix of less than equal to and greater than equal to or equal to. Then that time what to do, using slack variable you cannot find out the basic feasible solution. To construct the basic feasible solution, we need to add another variable that we can say a as artificial variable. So we have to introduce this a, then we can construct the first initial table. Okay, so that technique, why we add that and what is the benefit of that, so all those things is giving the idea to develop another method that is called Big M method. So these are the shortcomings we find in simplex method. So to overcome the shortcomings, we will introduce another artificial variable and a maximum value m. Okay, so we have to introduce minus m there, okay, for maximization problem, and plus m for minimization problem. Okay, So those things we are going to discuss next. So next is the working procedure of Big M method, or we can say the algorithm of Big M method. So step 1 is the first very basic step, that if we have LPP, okay, then we have to convert into standard form, standard LPP form, okay. Means whatever the physical problem is given in terms of LPP, that is called canonical form. So that canonical to standard we have to do, then only we can start the procedure, okay. So first we have to make sure that the problem is in standard form. After doing that, we have to check whether this has constraints positive, means greater than equal to, less than equal to type or not. Then how to introduce artificial variable, that just now I have told. So those things we are going to see. So say step 2 we will see those things. So we can convert this greater than equal to or equal to type of inequalities by adding non-negative variable. So if greater than equal to means what you are doing, you have to add some variable and you have to balance. So adding non-negative variable to the left hand side of all these constants. So these negative variables are called artificial variables, which help to obtain initial basic feasible solution. So the role of artificial variable is to obtain the initial basic feasible solution. Means we have to introduce this artificial variable so that we can get first or initial basic feasible solution. But the introduction of artificial variables violates the corresponding constraints. So whatever constraints is there, it may violate. We will see through example problem, it will be more clear. I will tell you. So to get rid of these variables as well as not allowing them to appear in the final solution, we have to assign, because we are here adding or we are incorporating artificial variable just to solve, okay. So in the solution we don't need that, we need only decision variable. So what to do to appear in the final solution, we have to assign a very large penalty. We have to write very large penalty minus m we have to introduce to these artificial variables in the objective function. We will see how to do that. So in the objective function we have to introduce this minus m value, okay, for the artificial variable. Means you can say that minus m is very large penalty value, okay, which will be introduced as a coefficient of a in objective function. This method is called also a penalty method, okay, as we are introducing minus m value here as a penalty. Now next is third step is very important, because here third step is that then solve the modified LPP by the simplex method. So here you see, if you know simplex method, Big M method is very easy. So already we have seen many problems on simplex method, so it will be very easy because all the steps will be like simplex method, okay, except first is that initial basic feasible solution. So initial table that we make, that is very important. So for that we need to introduce artificial variable and the concept of Big M, okay. After that the procedure is same as simplex method, we have to apply, but we may get the following three cases. As we have introduced m value, means minus m penalty, very large penalty value, and artificial variable, so after applying simplex method also we should take care certain things, and depending on that a artificial variable and the coefficient, we have three different cases. What are the cases that we will see? So here carefully observe. So if there are no artificial variable, like if we make the table and under the table if you have basis, na, so basis 1, basis 2, basis 3, like that, whatever depending on the problem. So in that basis if you don't have the artificial variable, okay, and the optimality condition satisfy. Optimality condition is called Cj. So for maximization problem, okay, what happened? Cj should be what? Less than equal to 0. If Cj value, capital Cj is what? Small cj minus zj. So if this value, all this value is less than equal to 0, means negative or 0, then we can stop the process. Yes or no? So if that satisfy, then what happens? This means optimal criteria satisfied. So optimality condition is satisfied. So if this is the case, Cj greater than, less than equal to 0, and in basis if you don't have, means no artificial variable, no a1 a2 artificial variable, then we call that, then the solution is an optimal basic solution, optimal basic feasible solution. Clear? Now the second case is that if there is at least one artificial variable, so among this, you see, maybe this one is your artificial variable, at least one, okay, 2 3 4 more can possible. If at least one you can identify that, okay, in the last table, okay, you have one artificial variable at least in the basis with 0 value, okay. B column means the constant what we have to write in equality form. If for that the changed, na, here you have to write basis, okay. Now x1 x2 something you will write, then here B column will be there. If the artificial variable a you are getting, okay, and for that corresponding a1 you are getting 0 here B, then that time what we will see, that is the thing. So this is the last table if we got, along with that Cj greater less than equal to 0, means optimality criteria satisfied, and one basic variable is your a1 means artificial variable, and the corresponding B value is 0 in that row, B value will be 0, then we can say that the solution is a degenerate optimal basic feasible solution. Clear? Different type of solution will come. I am just classifying different type of solution, okay. Now next, third type is also very important. So if there is at least one artificial variable in the basis with a positive B column, so now B value is positive. So instead of 0 in the previous case, if P is positive and optimal condition satisfied, then the problem has no feasible solution, okay. The final solution is not optimal since the objective function contains an unknown quantity m. M will contain. Such a solution satisfies the constraint but does not optimize the objective function, and the same is called a pseudo-optimal solution. So this type of solution, whatever you will get, that is called a pseudo-optimal solution. Clear? So we will see those things. Now step 4 is that continue the simplex method until either an optimal feasible solution or an unbounded solution is indicated. So whatever mentioned in the simplex method, that we are going to follow. So similar procedure is there. The only technique is the first to construct the first big M table. If that we can succeed, that making is succeed, then next is easy. So on the next section we are going to discuss about one example problem. The problem is this here: maximize z equal to 3x1 plus 2x2 subject to the constraint 2x1 plus x2 less than equal to 2, 3x1 plus 4x2 greater than equal to, you see here greater than equal to sign is there. It is a maximization problem. So if this type of problem is there, then what to do? So first we have to convert it into standard form. So this will be, objective function will be, z will be 3x1 plus 2x2. We will write other terms after that. Now here this one will be what, 2x1 plus x2 plus first slack variable that we have to add, s1 equal to 2. Now this one is 3x1 plus 4x2. Now we have to add surplus variable, means minus s2. If we do, then it will be 12. Okay, now this is done. Now next thing is that what will be the value here. If I take x1 equal to 0 and x2 equal to 0, then what happen, the first equation. So first equation, if this is first equation, this is the second equation. So first equation will become s1 equal to 2. So it is fine, s1 is 2. But second equation will be what, this is 0, this is 0. So you will get minus s2 equal to 12. That means we will get s2 equal to minus 12, which is not possible because s2 must be greater than equal to 0. Non-negativity condition is not satisfied. That's why we have to introduce another variable here. Okay, we have to add something here, a value, artificial variable, okay, to make it a perfect one, okay, standard form. So that we are going to do. See, then what will be the solution. So you see, second equation, we will start with second equation. So second equation is 3x1 plus 4x2 plus s1 contribution is 0, so 0 into s1, then minus s2, then plus we are adding another artificial variable, that is a, that equal to 12. So that will be done. Now what are the new variables we got? A. So we have to incorporate in equation 1. So equation 1 will be now changed into 2x1 plus x2 plus s1 plus 0 into s2 plus 0 into a equal to 2. Done. Now as we have introduced s1, s2 and a, we have to write here s1, s2 and a. But a, the coefficient is what, maximization problem, we have to introduce this minus m. So the final problem will becomes like this. Before starting the table, we have this one, maximize z equal to 3x1 plus 2x2 plus 0 into s1 plus 0 into s2 minus m into a, okay, which will be subject to 2x1 plus x2 plus s1 first slack variable plus 0 into s2 plus 0 into a equal to 2. Second equation, 3x1 plus 4x2 plus 0 into s1 minus s2 plus a equal to 12. Done. After that non-negativity condition, we have to write whatever variable we have used. So x1, x2, s1, a greater than equal to 0. Why not s2? Because we have added artificial variable here, so that's why we have written, okay, this x1, x2, s1, a greater than equal to 0. But s we may get as minus 12, okay, that's s2. That's why we have written like this in non-negativity condition. Now if we have this, then we are now in a position to construct the table, or we can use simplex table technique, simplex technique. So this is 3 is c1 value, constant value, this will be c2 value, 0 is c2, sorry c3, then this 0, c4, c5, like that we can write. And this is what is a11 value, this is a12, a13, a14, a15, this is b1 value, we can write b1 value, and this is b2 value. This 3 value will be a21, a4 value a22, a23, minus 1 is a24, a25 is 1. So those coefficients one by one we have to put. So we have to construct the table. So the table will looks like this. So first we have to write Cj and the Cj column, then under that you have to write basis, then the variables you have to put here. So first variable x1, second variable x2, third variable s1, fourth variable s2, and fifth one is artificial variable a. And corresponding to that, what is the coefficient of these variables in objective function, that you have to write for x1 3 is there, we have to write here in place of Cj it is 3, x2 2, s1 0, s2 0, and for a we have minus m. Clear? If it is clear, then next thing is that we have to choose the basis value. So how to choose the basis value, that we have to see. So before choosing we have to first write the coefficient. So coefficient of body matrix is 2 1, okay. Then next one is 3 4, and if you see the equation wise, so it will be 2 x1 1 into x2 1 into s1 0 into s2 0 into a equal to 2. So that we have to first write the coefficients here. So 2 1 1 0 0 2, the first row. Second row will be 3 4 0 minus 1 1 12. Done. Now if it is done, we have to choose which will be our basis. So for basis, you see the columns, you have to see the variable of the columns which will form a unit matrix. So you can see here 2 rows are there, so 2 cross 2 matrix can be formed. So 1 0 contribution coming from S1 and 0 1 contribution is coming from A, okay, A column. So that we have to write. So for S1 we have to write here this 1 corresponding, that's why S1 first basis element. Then for here 1 is contributing for A, that means A is coming as the second basis element or variable. Now for S1, what is the contribution or what is the coefficient of S1 in objective function? 0. So 0 we have to write the first entry in CB column, and then A is the artificial variable which will be the second basis variable whose contribution or whose coefficient in objective function is minus m. So that minus m we have to write as the second entry in the CB column. If you have to write, then it will be done. After that, next thing is that to find out the key column, then key row, okay, you have to write to get the key element, okay. That means we next thing is that we have to find out new variable, incoming variable, and which one will be the outgoing variable, okay. So that we have to do. So how to do? First we have to calculate zj value is what? CB aij, okay. So we have to take summation of CB aij. So first entry is 0 CB, so 0 into x1 here 2, so 0 into 2 0 plus minus 3 into m, minus 3m, so minus 3m we are getting. So 0 into 1, okay, this one. Next 0 into 1 and minus m into 4, so what we are getting? 0 minus 4m, we are getting minus 4m. Then similarly 0 into 1 0 minus m into 0 0, so 0 we are getting. Next is that 0 into this 0, so 0 minus m into 1, so minus m we are getting. So next one is 0 into 2 0 and minus m into 12, so minus 12m we are getting, okay. Now after getting zj, we have to find out capital Cj. So capital Cj is nothing but small cj minus zj. So small cj is here, so first entry in capital Cj will be this 3 minus 3m, that is 3 minus 3m, that is 3 plus 3m. Next one is 2 minus 4m, that is 2 plus 4m, okay. Similarly next entry will be 0 and then minus m, then next one is 0. Now after getting that, what I have told, m is very large number, okay. That means 3 plus 3m, 3m is large, again 4m is also very large. So if you compare 3m and 4m, m is very large, so 3 times and 4 times, so 4 times will be more larger than 3 times. So we can consider this element, okay, and using this element we can identify that this is the column or this is the key column. What we have means x2 will be the new incoming variable, okay. Now after getting the new incoming variable, what we have to find? The ratio. Now ratio how to find? We have to find the ratio by this dividing means b by this a ij value from the key column. Okay, so first one is 2 divided by 1, so 2 we are getting. Next 12 divided by 4, so 3 we are getting. Okay, now how to choose key row? So choosing key row, we need to see what is the smallest positive value in the ratio column. So smallest positive value we are getting as 2, and 2 is the first row, so we have to select this row. So this is the first row we have to take as the key row, and the second column as the key column, and the intersection point is your 1. This is the key element. So in the next step, what to do? We have to see the key element is 1, means we have to start with the first row. Okay, if this is the key element, first we have to see that whether it is 1 or other value. If any other non-zero value, we have to divide that, okay, to become or to make it 1. We have to divide that same value so that it will become 1. Then next thing is that below or above, if any elements are there in that column, we have to make it 0 by row operation. Okay, so that we are going to see in the next. So first we will replace this s1 by x2, because x2 is the incoming variable now from the key column we got, and s1 is the outgoing variable that we got from the key row. Okay, so that we have to change, and accordingly the entries will change. We will discuss that. So next table it shows, you see here, now in place of s1 it is coming x2. Okay, and we have to start with the first row. We have to start with first row. So first row will be what? As the key element is 1, so the row will be written as it is, same. So first entry is 2, so it will be 2, 1, it will be 1, then 1, it will be 1, 0, 0, same, and the b value also same. Now after that, what we have to see, I have told you that this is the key element 1, then only below we have one element, that is 4, so we have to make this entry 4 as 0. So how to do 4 as 0? So if you write R2 changes to R2, okay, R2 is 4, so what we will, if we add minus 4, then it will be done. So R2 minus 4 R1, then things will be done. Now if we do this operation, so first entry here you are getting minus 5, means 3 minus 2 into 4, so minus 5 we will get. Similarly here 0, then minus 4, minus 1, 1 we are getting, and the last ratio b value will be 12 minus 2 into 4, that you have to do. So 4 you are getting. After getting that, next thing is to find out the z value. Okay, don't forget to write the CB entry here. For x2 we had 2, that's why you have to fill that, and a minus m is there. Fine. Now zj is CB Aij, summation of CB Aij. That means 2 into 2 4 minus m into minus 5. So 4 plus 5m. Next 2 into 1, and then minus 4 into 0, so 2 we are getting. Third, similarly 2 plus 4m, fourth m, then minus m, then last one is 4 minus 4m we are getting. But to choose the key column, we need to first find out Cj, capital Cj. Capital Cj we have to find. So capital Cj if you find, then it will be 3 minus this value. So 3 minus 4 minus 5m, so we will get minus 1 minus 5m. Similarly 2 minus 2 we are getting, so 2 minus 2 0. Next 0 minus 2 minus 4m, so minus 2 minus 4m we are getting. Then next 0 minus m, so minus m we are getting. Next minus m, minus of minus m. So minus m plus m 0 we are getting. Now this we will get the Cj. So if you see the Cj row, neither of the entry is positive. Okay, means the entries are negative or 0. If we are getting negative or 0, that means we have the condition na, Cj should be less than equal to 0. This is the optimal condition, the optimality. So now the optimality reached in the second table. That means we cannot take the key column. So if we have reached, from this we have to tell that what is the solution. So this will be the solution, 4 minus 4m, but what you can tell, because m is there. Okay, if you see in the step 3 of the algorithm, the third case we have here. What is the third case? In the third case it is written, if there will be a artificial variable in the basis, okay, in the final table means optimality satisfied, optimal condition satisfied, basis, one of the basis you are getting artificial variable. And what about b? B value is positive here. So if positive b values are positive, then what we can say, it gives pseudo solution, means no feasible solution. If instead of positive 0, so it will be case 2. If we don't have a here, in place of a, if you have x1, let it be, or any other variable, x1 you can take, or you can take s1. So if you have that, then what happens? In that case you get some solution. Okay, so these are the three cases. When none of the basis variable is artificial variable, then you will get the solution. Optimality condition will be by default there, because we are discussing at the last table, okay, at the final table. And in the final table, if artificial variable are there, two things we need to see. One is whether b value is 0, okay, this is 0, or positive value, some other positive value, that we have to see. If 0, case 2, if 0 not 0, any positive value, like here we are getting 4, then it will be what? Case 3. Okay, so I hope it will be clear to all of you. If it is clear to you, then you can solve other problems. So here one thing I want to add here in the example problem, like instead of here, in place of maximization z, if you have minimization z, okay, in that case what to do? In that case, in place of this minus m, you have to add plus m. Okay, that means z will have something terms, and here plus m into a1, like that term will come. And other procedure will be same, like how you are taking minimization z, maximum, and then the solving the problem. So minimization case, the optimality criteria will be Cj greater than equal to 0. Okay, in that case, so slight modification changes are there. When we have discussed the simplex method, okay, in that lecture, you refer that lecture, there I had discussed about the minimization problem, how to solve, maximization problem, how to solve, using the diagram. Okay, using the flow diagram I have shown you. So those technique you can directly apply from minimization for minimization problem and maximization problem. No need to convert that, because okay, you no need to convert that. You add simply plus m into a there in case of minimization, and maximization minus m into a, like that you have to use and do accordingly. Okay, because they are here it will have greater than equal to, okay, that will be correct, but less than equal to is there, then the problem is happening. Okay, if you add slack variable in minimization, so this type of case will come. non-negative condition will be violated. Okay, that's why we are adding there plus m. I hope things are clear to all of you. And these are the practice set which you can take for practice and which you can solve, so that you will have good grip on this method.